We want to evaluate the indefinite integral. We just found this antiderivative using trig substitution, and now we'll show how we can use basic u-substitution to find the same antiderivative. Normally when performing basic u-substitution, we let u equal the higher degree part of the integrand, hoping that differential u fits the remaining part of the integrand. But in this case, we're going to let u equal the radicand of 1 plus 36x squared. So if we let u equal 1 plus 36x squared, notice that differential u would be equal to 72x dx. So if we divide both sides by 72, we could say that 1 divided by 72 differential u equals x dx. So looking at the integrand, notice how we don't have x dx, we have x cubed dx. So this x would take care of one of these factors of x, but we have a factor of x squared remaining. What we can do here is solve this equation here for x squared that would give us a substitution in terms of u. So if we solve this for x squared, we'd begin by subtracting 1 on both sides. Notice how that would give us 36x squared equals u minus 1. And now if we divide both sides by 36, we can say that x squared equals the quantity u minus 1 divided by 36. So now we'll perform substitution using u equals 1 plus 36x squared, 1 over 72 du equals x dx, and x squared equals the quantity u minus 1 divided by 36. Before we do this, though, let's rewrite this as the integral of x times x squared. Let's write the square root as the quantity 1 plus 36x squared to the 1/2. So now, again, x dx is equal to 1 over 72 du. Let's factor out the 1 over 72. We have the integral, and then we have du. And then x squared, again, is equal to the quantity u minus 1 divided by 36. Let's factor out the 1/36th, so we can have 1/36 times the quantity u minus 1. And then we have the quantity 1 plus 36x squared, which is equal to u raised to the 1/2 power. Now let's go ahead and distribute. 72 times 36 equals 2,592. So we have 1 over 2,592 times the integral of, this is u to the first, so we'll have u to the 3/2 minus u to the 1/2. And now we'll find the antiderivative with respect to u. So we have 1 over 2,592 times the antiderivative of u to the 3/2 would be u to the 5/2 divided by 5/2. Instead of dividing by 5/2, let's multiply by 2/5. So we'd have 2/5 u to the 5/2, and then we'd have minus the antiderivative of u to the 1/2 would be u to the 3/2 divided by 3/2, or 2/3 times u to the 3/2, and of course plus c. And after the last step, we'll substitute 1 plus 36x squared for u to find our antiderivative with respect to x. Let's go ahead and do this on the next slide. When we distribute here, notice how a factor of 2 will simplify out, so our fractional coefficient is going to be 1 over 6,480, and then we have u to the 5/2, which would be 1 plus 36x squared to the 5/2. And now for the second product here, a factor of 2 does simplify out, so we're left with minus 1 over 3,888, and then we have u to the 3/2, which would be the quantity 1 plus 36x squared to the 3/2, and of course plus c. So this would be our antiderivative. So if we compare this method to the trigonometric substitution method, as long as we recognize the substitutions using u-substitution, is shorter. I hope you found this helpful.